Good, how are you? How was
Good.
New York?
Oh, it was a lot of fun, but my knees and legs are killing me. Like
Um,
from like 1,000 steps a day to 13,000. Oh my God. Terrible. How are you feeling?
Fine. I'm
All
back to
better?
normal at school.
You're what?
Back to normal at school.
Uh-huh. And is Anka finally recognizing you as human?
Yeah.
Um, okay, I can't do 11 Friday. That's why I waited. I could do 10:30.
I have class then.
What about 9 to 10? You have class?
Wait,
You have to add, and I'm sorry. Wait, that's really late. How do you have class that late?
in the morning or
Yeah, like
wait,
I always talk my time. I'm sorry. So I was
wait,
saying
9 to
10:30.
10 p.m.?
No, 9 to 10
Oh,
a.m.
oh, I have class till 4 and then I have to walk a bit, but the US changed the time, but Germany hasn't, so now it's a 5-hour difference instead of 6.
So 9 o'clock is, oh, you sound great. Um, so what's the earliest you could do? Let's see.
Um,
I could do tomorrow 3 to 4.
your time?
Mm-hmm.
That probably works. Wait, so
That's what, 8
yeah,
o'clock your time.
yeah.
All right, let's do that.
Okay.
All right. You are in the system. All right, what's happening? We've done a little binomial expansion, haven't we? I think.
So she started binomial distribution. Well, she didn't start it. She told us to learn it. And I have and
Okay.
I don't understand anything from the textbook. So could we go through binomial distribution, please?
Expansion or distribution?
Distribution.
Do you have anything for me to go by?
Um, the textbook, I can share my screen.
Yeah, let me just see exactly what we're talking about here.
She wants us to go through exercises 14A through 14E.
14.1. Oh no, 14A through E, the whole thing.
Yeah.
Uh, Can I get access to this book? Or do you have to give me like passwords and junk?
No, someone found the PDF version and sent it to my class. So.
Oh, so can you put it in a folder or something?
Yeah.
Because you can't probably email that. Okay, your teacher said learn the binomial distribution. I just want to get that straight.
Yeah.
As in, I'm not teaching you anything about it.
She has COVID right now, so she can't.
She has COVID?
Yeah.
What are you gonna do?
I sent you the textbook on Google Drive.
Got it. Do, 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 do. Freya Young is the owner. Look at you.
How difficult would you say binomial distribution and the other distribution things are? It was frozen.
You were fading in and out, but I think you were saying, how hard is it?
Oh, okay.
Um, 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 it's not too bad. It's easier than calculus. It's just different.
Okay.
Okay, I think I got it. Yay. So I have to, there's no TOC thing, is there? What chapter is it? 14? Do you have a page number?
582.
You don't sound like you're better.
I just have a call.
Oh, you poor thing. 582? Oh, in the textbook. So it's not the same. Okay, got it, got it, got it. You know how to find the mean, I hope.
Mhm.
Right, right, okay. All right, I think we're gonna plow through the examples, Freya.
Okay.
That's the best I can do. I think at this point, okay. Where'd you go?
It was frozen again.
Okay, are we there?
Yeah.
Okay. Why is that doing that to me? Hmm. Can you go till 12:15? 5:15?
Yeah.
Okay. All right, so X be the random variable that represents the number of sixes. That's sort of important here. X is all the possible outcomes, and the outcome is the number of sixes, right? Not the actual value, but the number of sixes that come up when a dice is rolled 3 times, right? So the possible values that the random variable X can take on are 0, 1, 2, and 3 sixes. Does that make sense?
No.
Okay, you roll a die 3 times.
Yeah.
You could get 0 sixes. You could get 1 6 out of the 3, right?
Yeah.
You could get two of the 3 die could be sixes, or 3 of the 3 die could be sixes. You okay?
Yeah. Okay. No, it makes sense.
Yeah, that's why that was a little weird, because I was like, wait a second, it goes all the way up to 6. And how do you get no, it's just the way the question is stated. Okay, so if you roll a die, it's either 6 or not 6.
Mhm.
Right?
Yeah.
Okay. So then you just have to roll it 3 times doing each window. So then the second possibilities branch off. All right, if it is a 6, the second one could be a 6 or not a 6. Second one could be a 6 or not a 6. Right? And then you got to branch off for each of these for the third roll. 6, not 6, 6, not 6, 6, not 6, 6, not 6. And are you tree diagram friendly?
I understood them at one point.
Okay, so the way you start is a tree diagram starts at a point, right? And there's 2 outcomes, either a 6 or not a 6, right?
Yeah.
And I don't know why they didn't write this probability here. Getting a 6 is 1 out of 6, and not a 6 is 5 out of 6, right?
Mhm.
Okay, so the probability of getting Satan, Lucifer, the nasty, smelly one, is 1 over 6 times 1 over 6 times 1 over 6, right?
Okay. Yeah.
Okay, so that's the probability of 3 sixes. Yes?
Mhm.
And 2, 2, and 1, and 2, and 1, and 1, and 0. These are all that you have to go through and see all the different ways. You with me?
Yeah.
Okay, so capital X just is, it's like the umbrella. It represents all of the possible outcomes. And the little x is the specific outcome. So this is just saying the probability that the random variable x equals 0 or 1 or 2 or 3. And they're listing the probabilities here.
Okay.
Is that okay?
Mhm.
Okay, so with 0, I just have to go down and do all the zeros. We'll do 0 in green. So 2, 2, 2, 2, 2, 2, 2, 1, 1, 0. There's only one of them, right? 125 out
Yeah.
of 16. So how many ones are there? 1, 1, 1. That's it. Is that right? 1, 1, 1. Yeah, so that's 75 out of 216, which simplifies to 25 out of 72. Is
Okay.
that okay?
Yeah.
And then 2 is 5, or 2, 2, 2, yeah? How come it didn't work? Come on, pen. 2, 2, 2, so that's 15 out of 16. That simplifies to 5 out of 72. And then 3 6s, there's only one way there. 1 out of 216. Right? Okay. So all of these probabilities must add up to 1.
Okay.
Make sense?
Yeah.
And you know how to find the probability using a tree diagram. Tree diagrams rule. Okay, so for any random variable, this is true. And that is that the probability of really anything occurring, this is not new news, is between 0 and 1. Right?
Yeah.
And then the sum of the probability of a particular event, the sum of the probabilities is 1. Always. Right?
Yeah.
Okay. So let's do this. So just forget about the questions. Just tell me what the table means. Like, pick a particular value of low x and just tell me what's going on there.
So X is something. So then the probability that X happens one time is 7C.
Very good. And how might we find the value of C?
7C plus 5C plus.
Atta girl. I get 1 out of, excuse me, 20.
Mhm.
You got 1 out of 20?
Yeah.
What's the probability that the random variable x is greater than or equal to 4?
Is that 7 times 1/20th plus 5 times 1/20th? And then plus
No,
4 times.
greater than or equal to 4.
Oh. 3/20th plus 1/20th.
You sound even more. I can't think of the word without being mean, and I don't want to be mean because I'm not trying to be mean. You sound more awesomely pathetic than you usually do with in your recovery voice. I love it. All right. I'm gonna randomly pick a random question, random variable thing. Wasn't that sort of funny? Not at all. So, okay. The probability distribution is just like a table like this, right? It just shows
Yeah.
all the probabilities of all the events, and it doesn't necessarily have to be a table. You know, it could be a list, but a table is a bit more helpful. All right, what do you want to do? And you cannot curl up in a ball and cry. That's not an option. That's only an option for me.
I don't know.
Has anyone else told you this about your normal speaking voice? Or is it actually a sad cry for I don't know what's going on. Okay, the probability that X is greater than or equal to 2. What is that?
3 times the probability that it's less than 2.
Yes, I know that, but in order to do that, little Miss Smarty Pants, I got it. Oh my God. Please tell me you did that on purpose just to annoy me.
No, I don't know what the question is.
Okay, it says find where determine the values of A and B. So this is all we have to go on, right? Okay. And then this tells us all about it, doesn't it? All the different probabilities. So the probability that X is greater than or equal to 2 would be the probability of 2 plus 3, the probability of 3 plus probability of 4 plus probability of 5. Would you agree?
I'm confused.
What's the probability that X equals 1? Oops, I forgot 0.
Also the probability that it equals 2 and 0.
Yes, which is equal to what?
A.
There you go. So look at this pathetic little chart. So it's 1 is A and 2 is A, right?
Mhm.
What's 3?
B.
4,
B.
5.
Also B.
Good. So then what's the probability that X is greater than or equal to 2?
0.
Well, what's the probability that X equals 2?
A.
3.
3 what?
Probability that X equals 3.
B.
4.
B.
5.
B.
Right. So 2, 3, 4, and 5 are all greater than or equal to 2, right?
Mhm.
So then the probability that X is greater than or equal to 2 is A plus 2B, 3B. Are you there? Shoot,
It froze.
I know. Are you there?
Yeah.
All right. Yeah, your picture went away too.
I think that'll make the connection better because I have horrible Wi-Fi.
Oh, so you think it's my fault or your fault? Okay.
Yeah.
Oh, I don't get to see your sad, terrified expressions. It's the only reason I tutor you. What is the okay, so now it's equal to 3 times the probability that X is less than 2. So that would be 1 and 0. So that would be 3 times 2A, right?
I'm so confused.
All right, what are you confused about?
Um, well, I understand the table,
Uh-huh.
and how you made the table from what's given, but I don't understand anything else.
So let's say I had this same table. I'm not going to put, well, I will. I'll just put little x and capital X. Okay. I'm not going to put this is capital X is the probability. Yes. Zero, 1, 2, 3, 4, 5. Say the probability that you get 0 is 1 out of 10. This is 2 out of 10. This is 3 out of 10. This is 2 out of 10. 3, 4, 5, 6, 7, 8. Actually, that's the rest of these are 1 out of 10. 3, 4, 5, 6. No, this is 2 out of 10. 7, 8, 9, 10. Right? Let's just say that was true. You with me?
Yeah.
Okay. What's the probability of 0?
10.
Yes. What is the probability that x is greater than or equal to 2? I'm sorry?
Is that where the things that are greater than or equal to are added together?
Yep.
Or, okay.
So what is it?
3/10 plus 2/10 plus 1/10.
And do you think you could give me a total?
Oh. Um,
7.
yeah.
Okay, and what's the probability that x is less than 2?
3/10.
Yep, and you shouldn't even have to add it because they should combine to be 1, correct?
Yeah.
Okay. So they're telling us that the probability, we don't have numbers, we just have letters, right?
Yeah.
So x greater than 2 is a plus b plus b plus b, right?
Mm-hmm.
And then the probability that less is less than 2, it's a plus a, isn't it?
Yeah.
So do you see where I got the a plus 3b for x greater than or equal to 2 then?
Yeah.
Okay, and then so this would be 3 times 2a, is that cool? All right, so we got a plus 3b is equal to 6a, right?
Mm-hmm.
Okay. That's two unknowns in one equation. This is no good, right? We can't solve for a and b, and that's what they're asking us to do, isn't it?
Mm-hmm.
These horrible, mean people. However, isn't there another equation we can write with the a's and the b's?
Is it one of the ones that's given?
No, it's one that is true about every probability distribution when you have a particular event, like the probability of rolling, you know, a 1, 2, 3, 4, 5, or 6 on a single roll of a die, right? All of the probabilities added together must be equal to what?
1.
1, right? So that means
Yeah.
that all of the A's and all of the B's must be equal to 1, right?
Mhm.
So can't we say now that 3A plus 3B equals 1?
Yeah.
Okay, so here's my system, right? So I'm going to use substitution. Since I see a 3b here, I'm just going to solve for this 3b and say that 3b equals 1 minus 3a. How's that?
Okay.
Okay. So then I can say that a plus 1 minus 3a equals 6a. 1 equals 8a, moving a minus 3a over, which is negative 2a.
Yeah.
1 over 8 equals a. Woohoo! And then what? What? 3b. 3b equals 7 over 8, actually, right? No, it doesn't. Sorry. So we'll plug in here, right? 3b equals 1 minus 3 times 1 over 8. Is that all right? You see where I got that? Gosh darn it. Okay, so then 3b equals 1 minus 3/8.
Yeah.
3b equals 5/8.
Mhm.
b equals 5 over 24. Divide both sides by 3, multiply by the reciprocal. 5 over 8 times 1 over 3 is 5 over 24. Fractions. You okay with that?
Yeah.
I was kind of trying to be mean. Oh gosh. Okay. Hoorah! Determine the probability that the sum of two independent observations from this distribution exceeds 7.
What does that mean?
It means find the probability that I observe it once and I observe it again, and the values of x are greater than 7. So how many ways can we get greater than 7? So I have to get
The
rid of
blue
this red
table?
thing. I'm gonna have to get rid of this red thing because it's gonna be confusing.
Okay.
Because it was just our teach Freya what's going on example. So it's down here for your, you can frame it or something. I don't know. Okay, so now we know that A is what? 1 out of 8. So 1/8, 1 out of 8, 1 out of 8. Was it 5 out of 24? Yep, 5 out of 24. 5 out of 24. 5 out of 24. We good?
Yeah.
Okay. So they're saying that what is the probability that x equals little x plus I don't even know how to write it with the correct notation. How's that?
Mm. Okay. But it only gives up to 5.
Right, but we're gonna look at it twice and add the results.
Okay.
So we have to think of the different ways that we can get greater than 7. So can we, if the first one is 0, if we add something to it, can we get greater than 7?
No.
No. What about 1? Does 1 plus anything equal 7?
Yes.
1 plus what?
6.
Okay, no, that equals 7, but let's just assume you said 7. Because it needs to
I'm
be,
confused.
okay, here it is. Think of it this way. In a bag, I have a 0 marble, a 1 marble, a 2 marble, a 3 marble, a 4 marble, and a 5 marble, right? And these are X. And I'm going to draw 1 marble and put it back in. And then I'm going to draw another marble and put it back in. Yes?
Mhm.
First draw, second draw. But under second draw, okay, no, I'll just put total. Right? So if I draw a 0 and I draw a 5, that would be the greatest, wouldn't it? That would be 0 plus 5 is the total, yes?
Yeah.
Okay, so no go, right? If I
Yeah.
drew a 1, what's the greatest total I could get?
6.
Yeah, 1 plus 5 is 6. What about a 2?
7.
Yeah, we're still not there yet, are we?
Mm. Because it has to be greater than 7.
Yeah, that's the thing. It
Okay.
exceeds 7, right?
Mm-hmm.
Okay, so what about a 3? What's the greatest?
8.
Yeah, 3 and 5 is 8. Is there any, so here's the cutoff, right?
Yeah.
Okay, what about a 4?
9.
Right? Is there anything else I could add to get greater than 7?
5 and
Right?
5.
Well, no, with the 4, I could do 4 and 4 and get 8, couldn't I?
Oh.
Right?
Mhm.
Okay, and then let's say I do a 5. Well, 5 and then 3 is 8. 5, 4 is 8. And 5, 5. Oh, 5, 4 is 9, whatever. Right?
Yeah.
So these are all the different ways,
Okay.
right? So I need to determine the probability. So that's going to be the probability of 3 then 5, right?
Yeah.
Plus 4, 4, plus 4, 5, plus 5, 3, plus 5, 4, plus 5, 5. Would you agree?
Yeah. But how do you find the probability of 3 and 5, for example?
Well, the probability of two events occurring is the probability of the first multiplied by the probability of the second. So in order, that would be of 3, 5 would be 5 out of 24 times 5 out of 24, wouldn't it?
Yeah.
In fact, all of these numbers are 3 and greater, aren't they?
Yeah.
And all of the 3 and greater, their probabilities are 5 out of 24, aren't they?
Yeah.
So then each of these, each individual probability is 5 over 24 times 5 over 24, right?
Mhm.
And there's 1, 2, 3, 4, 5, 6 of them, isn't it?
Mhm.
Or aren't there? So couldn't I just do this? So that would equal 6 times that, wouldn't it? Because there's 6 of them.
Yeah.
Well, this is exciting. And you know what? Let's make our life a little bit easier, because can't we well, let's simplify it right now. This is like 6 over 1, isn't it?
Mhm.
So can't I do 1 and 4 here?
Yeah.
Okay, then we just have to do 5 times 5 is 25. And 4 times 24 is 96. There we go. Isn't probability great?
Mm.
All right, let's try another one. Let's try number 9, because I'm assuming it's the hardest one. It's the last one.
Are these all from 14A or
These are all from 14A. How soon do you have
how
to learn
does,
this?
yeah, how does it change as the chapter goes on?
That adds more things. I don't, I don't know how to answer that. What do you mean? Oh my God, look. Oh, okay. This is still 14.1.
Is
It's
this
just, what's that?
is this binomial distribution?
That's the next section.
Oh,
But you got to understand this to be able to do binomial distribution.
okay. Can we do in the last 15 minutes one binomial distribution question? I'm scared she'll yell at me because I didn't do anything.
Are you coughing or laughing or crying?
Coughing.
I'm not sure if you're allowed to say you don't understand, though. Oh, no, I think it's going to be okay. Do your friends laugh at you like I laugh at you?
No.
No, they're nice. All right, I'm sorry. All right, X
I
is a,
think they're scared I have COVID for a third time.
no, I mean, no, you're naturally funny, and I don't think that you know that you are. Anyway, that's what I mean, not the whole COVID thing. Generalizing the method. Okay. So a binomial distribution means that either you have an experiment where it's true or it's false. For example, let's say you're flipping a coin and you want it to be heads, right? So heads is true and tails is false, or there's just two possible outcomes. How's that?
Okay.
Like tails or not tails, maybe could be it. Or you don't have to just have two possibilities. Like probably the first thing we did was probability of a 6 or not a 6. Like it's a pass fail thing.
Yeah.
You with me?
Mhm.
That's what we use binomial for. And do you remember the binomial distribution, like a plus b squared, or a plus b cubed, or a plus b to the 12th?
Like finding the coefficient.
Yeah, all that crap.
Yeah.
Okay, now we never really expanded a big, long, nasty one, but as it turns out, those coefficients can, or that distribution also works for probabilities, okay? And this formula here looks a bit familiar, I hope, remember?
Yeah.
Okay, the only difference is this 1 minus p, which we define as q. So this is really the dealio right here. But we have to remember that q is 1 minus p. Don't ask me what p and q are just yet. Okay, you ready?
Yeah.
Okay. So the way this book is using it is the trial is either a success or a failure. So the probability of success in each trial is 1 out of 5. So the probability it's a failure would be what?
4/5.
There you go. Okay. What is the probability of exactly 4 excesses? So what we say, the notation is that X is, let me see how your book is going to put it, the symbolism. Can you go past the 15 if we have to?
Yeah.
Okay. Well, I'm not exactly sure, so I'm going to wing it. This says that X is a binomial distribution with 6 trials and a success rate of 1/5. How's that? That's all that means. And you'll see it in I don't remember you having to write that down on your IB exam. This is the important part. Okay, what's coming. So what we're being asked for is a probability of exactly 4 successes. So what we're being asked to do is to find the probability that the random variable X is equal to 4. And the random variable is either success or failure. You okay?
So if it's success or failure,
It's a binomial distribution.
why is there one variable for success and so there's one variable for success and failure? Or
I don't know what you mean by the variable. What
so
variable?
if x equals 4, x can either be a success or a failure?
Yeah, in our little table, right? Little x, probability that big X equals X, success or failure. Those are the things. And then the probability of success is 1 out of 5, and this is 4 out of 5.
And when it's x is equal to 4, how do you know if it's a success or not? Or
It's
how do you
not,
know what it's
it's
talking about?
this is exactly 4 successes. That's all. That's what this 4 is. So it's 4 of these. 4 successes.
So 4 times 1/5?
No. We have to use this formula, right?
Okay. Wait, why that formula?
So here's the thing, Freya, you asked to skip to binomial distribution to do one example. So we didn't get to do the y, okay? But as it turns out, a plus b to the n power, if you recall, instead of writing it down, I'll just get it from the formula sheet. Where did it go? Oh, it's going to be in functions. Silly me. Okay. Remember this?
Yeah.
And this is a binomial distribution, correct? And it just expanded, you know, a plus b to whatever exponent we needed, right?
Yeah.
And the general term was this guy, right? We could find, remember, we use this to find any particular term that we needed. Okay, so turns out mathematically that this also can help us find the probability when of a binomial experiments where there's either success or failure, because there's only 2 things, right? 2 possibilities, 2 possible outcomes, success or failure. You with me?
Yeah.
Okay. So we can use this same distribution, if you're going to trust me on that, to find probabilities, right? It's the same one, it's just manipulated slightly, but it's the same thing. Okay. All right. So if X is a discrete random variable, which is binomially, oh my God, binomially distributed, X is binomially distributed, n comma p, then the probability of containing R successes, R is the number of successes, out of n trials, n is the number of trials, R is the number of successes that we want. When P is the probability of success, P is the probability of success, then the probability that X equals R, right? So this is number of successes. N is trials. Again, number of successes. And P is the probability. You with me?
Yeah.
Okay. So we're just plugging in and chugging. So this is going to equal N. How many trials are there in this stupid binomial experiment?
6.
How many successes are we looking for?
4.
Okay, so we took care of this guy. What's the probability of success?
5th.
1/5 times the probability of failure, which is Q. Oh wait, 1/5 to the R. 1/5 to the R, sorry. 1/5 to the R is 4, right? R is 4. And what's the probability of failure?
4/5.
Yes. To the N minus R. Well, it's going to be 2. These guys always add up to 6. Or the number of trials, right? Or the N. Always. Done.
Okay.
Get out your calculator.
How do I do NR? Is that N choose R?
Yep. And you're going to remember
I got 9.15 times 10 to the negative
that's
4.
because the medicine, you got what?
9.15 times 10 to the negative 4.
That's because the medication they gave you for the COVID was crack cocaine. Now you are in scientific notation. I just don't like the 9. Did you do your fractions and exponents correctly?
Oh, no.
Okay. Then I'm going to get up and get some water while you do them correctly, okay?
Okay.
All right. Do you have an automatic water thingy in your fridge, wherever it is, or do you have to just use the faucet for the German water?
Just this thing. I don't
Yeah,
think I've seen a refrigerator in Germany yet with a water thing.
really.
Yeah.
So
Okay.
what you're telling me, it's like 1960 in Germany.
Yeah.
Okay. There you go. Okay, wait, what kind of calculator do you have?
PI 84 plus CE.
God. Oh God. All right. Well, we're going to spend a little more time if you have it. Okay. All right. So now they want to know the probability that X is at least one success, right? So that would
Yeah.
be greater than or equal to 1, wouldn't it?
Yeah.
Now, do you want to do 1, 2? So there's 6 trials, right?
Mhm.
So we would have to do the probability of success on 5 of them, right? Because the possibilities are 0, 1, 2, 3, 4, 5, 6, whatever. But if we're smart, then we could think of this as 1, which is the sum of all the probabilities, right?
Yeah.
Minus the probability that X is equal to 0. That's how we can change it into a binomial experiment, right? Because
I'm
it's
confused.
either 0 or it's not. And if it's not 0, it's greater than or equal to 1, correct?
I don't get it.
So if there's at least one success, right?
Yeah.
Here's the possibilities. There could be 0 successes, 1 success, 2, 3, 4, 5, or 6 successes, correct?
Yeah.
So, and all of these probabilities, whatever they are, equal 1, right? You add them all up. Yes?
Yeah.
Okay. So red are the successes we want. There could be 1, 2, 3, 4, 5, or 6 successes. That's what they're asking for here, correct? And this is the 0 is no successes. So we don't want that in this guy, correct?
Yeah.
And let's just say blue is the whole dang mad experiment. All the probabilities, right?
Mhm.
So if I took blue minus green, don't I get red?
Yeah.
Okay. Well, blue is the probability that X is 1. That's the total, isn't it?
Wait,
It's,
blue is isn't one success or
this is probability now, because we're being asked for the probability, aren't we?
yeah.
Right? And the probabilities always add up to 1, right?
Mhm. Yeah.
So this would be 1 minus probability that X equals 0. That's what green is, right?
Yeah.
And we went left with the probability that X is greater than or equal to 1.
Okay.
Okay, so this is going to equal 1 minus. So the probability that X equals 0, going back to our general formula, equals N, right? N
Okay.
is 6. And the probability that X equals 0 is the probability of the event, which is 1 out of 5, right?
I'm confused
Oh no,
now.
0. I don't know. I'm sorry. I put that wrong. I'm sorry. This should be the our R is 0. We want to know how many times we can get 0 successes.
Okay.
Okay. Times a probability, which would be 1/5 to the 6th times 4/5 to the 0. Yes?
Yeah.
Here we go. Please, I'm begging you, lay off the crack on this one, all right? By the way, 620 is 1. By the way, anything to the 0 power is 1.
.99.
Oh, this is R. This is R. This is R. Sorry. In the formula, the P is the R. My bad. This is the 0. This is the 0. My bad. And this is the 6, right?
Okay.
So sorry. I got my R's mixed up.
0.74.
0.738. 3 sig figs, please. All right. If you are ever able to use your calculator, I'm going to show you how to do it. TI stupid 84, what, C plus or some nonsense? What is it?
Plus CE.
Plus freaking CE. Okay. All right. So this is how you can do this without having to think, with barely having to think. Okay. So first of all, for A, we're going to write down what everything equals. We know that N equals 6.
Yeah.
Right? R is
Mhm.
4. P is 1/5. And Q is 4 out of 5, which is success and failure, correct?
Yeah.
You okay?
Mm-hmm.
All right. Can you hit second bars?
Mm-hmm.
You see the distribution option? The ISTR?
Not yet. No.
All right, let me see your calculator.
Oh, the menu. Okay.
God. Yes, now go down to binom. Okay, now here's the thing. Stop. Stop, 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 stop. So we are being asked to find the probability of an exact number, correct?
Mhm.
Just 4 successes.
Mhm.
For the second one, at least one. So that's a 1, 2, 3, 4, or a 5, right?
Yeah.
Okay. So what we're doing now is when you're only being asked to the binom PDF specifically is when you're finding the probability of one occurrence of just one thing. Okay. And in this case, we're looking for the probability of 4. Do you agree?
Yeah. So the calculator only works if it's one thing.
No, it will work with more than one. I'm just saying that this is the one that you choose. There's a binom PDF and a binom CDF. CDF is for 1. Or I'm sorry, PDF is for 1. Okay.
Mhm.
All right. So hit binom PDF and then it appears on your screen or some crap.
Yeah.
Okay. So put in that n value in for n, which is 6,
Mhm.
comma, p, which is 1/5,
Mhm.
comma,
Yeah.
hold on.
It worked.
Got it?
Mhm. Yeah.
Is that the bomb or what?
Yeah.
Okay. So here's how I remember it. PDF is for a particular number. I don't know if that's what it stands for or not. I don't know. Okay. Now go back to that menu again,
Mhm.
and we're going to do CDF. C is for cumulative. Oh, am I sharing?
So a fifth. Yeah.
I'm still sharing. So hold on. I have to look at this thing. You probably already figured it out, you Gen Zer.
I don't know what to put for X.
This stupid calculator on the Inspire, you don't have to think about what I'm gonna tell you. Ugh. Okay, your stupid calculator will only do less than, it won't do greater than.
Okay.
So you could go back to, I'll do a little more research. I don't want to take the time right now, because maybe there is a range, like I was hoping you could just do 1 to 6, right? But you can't, so the probabilities are different. No, if it's success or failure, I'm just thinking. So, okay. It could be successful 0 time, 1 time, 2 times, 3 times, 4 times, 5 times, or 6 times, right?
Yeah.
Okay. And we're trying to find that it's greater than or equal to 1. Yes.
Mhm.
So we're just looking for 5 successes.
Mhm.
The probability is the same.
How?
For each one, like it's 1/5. The
Oh, yeah.
probability of success is 1/5, right? Okay.
Mhm.
So as far as our calculator is concerned, I think it doesn't matter cumulatively where we start. As far, because like I said, they only do less than. I just need 5 things, right? So if I do less than or equal to 5, that's 5 things. 1, 2, 3, 4, 5. That's 6 ways, which greater than or equal to 1 is also 6 ways, or 6 successes. You following me? Huh?
X is 5?
Mm, just hold it. Forget about all that crap.
Okay.
Okay. We need 5 successes, right? That's what X is greater than or equal to 1. It could be either 1 or 2 or 3 or 4 or 5 successes, or 6
Why
successes.
5?
I'm sorry, 6.
Okay. But 6 is the maximum?
Yes, because greater than or equal to 1, it's either 1 success, 2, 3, 4, 5, or 6 successes. Yes?
Mhm.
Okay.
Yeah.
Okay. That's no different than 0, 1, 2, 3, 4, or 5,
Okay.
right? Because there's 6 of them as well. So in order to get 6 in, okay, since this starts at the top and goes down, we're going to find the probability that X is less than or equal to 5 instead of greater than or equal to 1, because that will be the same probability.
Can you repeat that, please?
The problem is your stinking calculator will only do less than or equal to.
Yeah. So why is
Okay.
it less than 5?
Because with less than or equal to 5, I have 1, 2, 3, 4, 5, 6.
But 0 isn't 1.
Sure it is. There's a probability that you get 0 successes, isn't there? For example, if you roll a die 6 times, right?
Yeah.
You could get 0 sixes, 1 6, 2 6, 3 6, 4 6, 5 6, or 6 sixes. Am I right?
Mhm.
So 0 is
But
there is a probability to get 0.
why Is it included if it says at least one?
It's not included. That's not what I'm talking. You're asking me why. You're asking me why I'm doing x is less than or equal to greater than or equal to one. Well, okay. Okay. No, I'm not gonna. I'm gonna try and find a way for you to put in the range. For now, let's go back to you could do again 1 minus the probability that x is equal to 0, right?
Yeah.
Okay.
I do have to go soon though.
Like how soon?
10
5 minutes?
minutes?
Huh?
No, like 10 minutes.
Okay, we can do this. This is it. Remember, it was 1 minus probability of x equals 0. And then
Yeah.
we had to do, like, we had to do all this crap, right? I'm saving you from this crap.
Okay.
Now, 1 minus probability of x equals 0. So on your calculator, 1 minus
Mhm.
second bars distributions,
Yeah.
and do the same thing that you just did.
Yeah, for PDF.
P, because all we're doing is x equals 0.
So trial 6 and 1/5.
Uh-huh. And then 0.
Okay.
What do you got?
Oh, 0.738.
That's exactly what we got before, isn't it?
Yeah.
Okay. Much quicker than having to enter in all this junk
Yeah.
and figuring out all this junk. Right?
Hmm.
So you should, that's what you should do. It's totally what you should do. So you've done a binomial. How about that?
Okay.
Why do you have to go in 10 minutes, Freya?
I have to submit my history IA today.
It's history. All right. Have a good day. And what did we decide? Tomorrow sometime? I forget when.
8 p.m. my time, so 3 p.m. your time. I think.
Hold on. Oh, we call that. Where's the stupid Google Calendar? Oh my God. That's correct. Bye.
Thank you.
You're welcome. Thank you. Stop
Yeah.
coughing. God.